Well, hey guys, today we're starting on chapter 4, which is all about sampling methods and experimental design, which you probably didn't think was part of AP statistics, and yet what we use statistics most often for is crunching those numbers that comes out of experiments and from surveys. So we're going to do a quick survey and take a look at the kinds of things that need to go under consideration when you're creating the data for your experiments. So let's get started on the next screen. Here we go. We have ourselves the question, what is the average word length of a Beyonce song? So when this was created, Crazy in Love was a big song, and the question was asked, what is the average word length here? And I think this had to do kind of with authenticity and who wrote this song. And one of those indicators is the average word length of different songwriters will be different from songwriter to songwriter. They vary. So we've got ourselves the lyric sheet for Crazy in Love right over here. And we're just going to circle a few words. So what words are we going to circle? Okay, so, I see a lot of looking. I also see a lot of crazy. What else can we do? Oh, friends. Pick friends. That seems to be kind of representative. What else do we got? So. So is a word that we see repeated a lot. Then lastly, I think we're going to pick this word right here, foolish. So, looking crazy, friends, so foolish. Okay, so obviously the words that you pick will be different, but the point here is that you yourself are picking the words. So of course, everyone's word selection is going to be different, and answers are going to vary here. So what's the average word length here? Well, let's write down the word lengths here. We've got 7 for looking, 5 for crazy. The word friends is also 7. So is 2 letters long, and foolish is 7 letters long. And then, of course, we can find the average of this sample of 5 words. This gives us an average word length of 5.6. Now, what we would do in class is, since everybody in class is going to do their own average, we're going to create a distribution of averages. So let's go ahead and take a look at the distribution of averages. So I got this spreadsheet that I've created, and we have the entire lyric sheet of Crazy in Love with the position in the song. So the 13th word in Crazy in Love has 3 letters, probably U or something like that. And then keep on going. We've got maybe 113th word has 2 letters. I'm guessing so, or maybe in. And all of 297 words of the song Crazy in Love. The length of each word is here in the spreadsheet. Okay, 1 year we took the averages, and this is what we found, this is what the class did when they picked their own words, their own set of 5, the averages. Well, we got this first person got 2.8. This is a 3.4. This person got a word average of 5, 5.4, etc., etc. Then we took those averages, and we created a dot plot of those averages. We see that right over here, the dot plot of those averages. Putting these into our worksheet, so let's take a look at these averages. The first thing I want us to realize is this is kind of an uncoordinated effort here to figure out figure out the average word length. Everyone just kind of did their own set of 5, and everyone just kind of picked whichever words they felt like, whatever was working for them at the moment, that's the words they picked. So whenever we do that, whenever we just pick words without rhyme or reason, or maybe with a rhyme and reason that doesn't really fit with the program, it's basically just whichever words are easiest to get to, we would call this a convenience sample. Basically what this means is we systematically chose words that are easy to get to. And now the easy part of this might be kind of deceptive, because what we're really saying is that we didn't make an effort to randomize, or we made a minimal effort to randomize. So that's what we mean by easy here. Not that any of this was particularly easy to do. It's just that we didn't make an effort to randomize. We just pick whichever words we wanted to. So whenever we use a convenience sample, most likely this sample is biased. Now, I know what you're saying. What do you mean biased? I just chose any words. There's no bias here. And that's because bias has some kind of political overtones with it a lot of times, or it has a definition that is different in everyday use than the definition that we would use in statistics. So when we say biased in statistics, we don't mean that, we don't like a group of words, or we don't like a group of people, or, there's no dislike involved with bias. So bias in statistics means that the results of a survey are going to be different than what was actually meant to be measured. So we meant to measure the average word length in the Beyonce song. So in this case, the average word length from the survey is not the actual word length of the average word length of this song. By the way, what is, based on this survey, what is the average word length? Well, that's actually kind of a hard thing to figure out. We have a pretty large spread of values here, ranging from about 2.8 to about 7.2 on the right side. And, we kind of get average, we kind of get peaks. There's no single peak here, or no distinct peak. And if we had to kind of eyeball this average, you would probably eyeball the average right about here. Maybe right around there. So perhaps the average is right around 4.6. Well, let's talk down from that 4.6, because let's remember that the number of words in Beyonce's Crazy in Love, that's only 297 words. So it's actually relatively easy just to count all the words and find the actual average. And let me tell you, the actual average is probably not 4.6. What is the actual average? Well, how can we better sample? So we're going to find a new sample of words using a random number generator. Okay, and we're going to put that average on a dot plot. So let's talk about how would you do this with a random number generator. So here's our TI-84, and if you've never used the random number generator on your calculator, which I'm pretty sure you haven't, the first thing you want to do is get a number. And I usually tell my class to grab your birthday. And then you're going to take that number and you're going to push a store button. That's going to be right above the on button over here. Notice it in red. And you want to store that into math. Push to the right a couple times until probability is highlighted. And then you want to store that in rand. So this is what your screen looks like. You should say your birthday, store, the arrow, and then rand. Push enter and it's just going to give you your birthday back at you. Basically what happens is your calculator needs a first number to start off, so everybody has a different random number in the class. So it looks really funny when everyone's using their random number generator and they're all getting the same numbers. Well, that's going to happen if you have factory calculators. So if you have a factory reset, you're going to want to do this same thing. Okay, so now that we have our random numbers our random numbers seeded, they call this seeding your random number generator, you're going to want to take the entire list of numbers, which I'll remind you was 297 words, and you want to put them in a random order. So the way to do that would be to click the Math button, and then you're going to go to Probability, scrolling to the right, and then you're going to use the option at the very end, which is Rand Int No Repeat. Okay. So we're going to do lower 1, upper word number 297. Now, you're going to hear me call those ID numbers, and those are basically just each individual word on the lyric sheet has an individual number. That's why we're calling them IDs. Sometimes your calculator will allow you to put how many do you want, but sometimes it doesn't. It just kind of depends on the operating system of your calculator. I'm going to put 5 here because I want to pick 5 random words or ID numbers from 1 to 297 without any repeats. So I'm going to click that. I'm going to push enter, and it gives me these 3 words: word 181, word 183, word 1, 265, and 158. Okay. Sometimes, I said this before, sometimes some calculators, they don't want you to have the 5 there. So we'll just do 1 to 297. And what that's going to do is it's going to randomize all 297 words and give you all 297 in order. So in this case, you would just pick the first 5. 1, 2, 3, 4, 5. 158, 190, 174, 235, and 207. So it all kind of depends on whether or not you can put in this extra number. Otherwise, you just order the entire list and take however many you need for your sample. Now, taking these 5 numbers, 158, 190, 174, 235, and 207, I can go back to my lyric sheet and look for those words. 158, let's highlight 158. Look. 190 is I. 174 is dress. 235 is got. 207 is I don't. Sorry, just don't. So those are now my 5 words. And what happened here is, when you think about what's actually happening is, when you are choosing the words on your own, you're kind of systematically avoiding the really short and the really long words. That's usually what people do. Like, I would almost never ever choose the word I, because that's such a short word. It seems like it shouldn't make a difference to the sample. So now that I have these 5 words, I can go ahead and get an average and put those in the dot plot. Now, if you happen to be working with a list like this, we're going to do a lot like what we did with the second one, and we can just randomize the sheet by column A. So we'll select the 2 columns. One of them is an ID number, the other one is a number of letters, and then we could randomize the range, and that will give me, then I'll pick the first 5, 2, 3, 1, 4, and 6. Again, you notice that it picked a word length of just 1. So those are two ways of randomizing without replacement. And so from that first sample that you saw me pick, my average was 3.4. And again, we can go ahead and put those numbers and create a dot plot using everybody in the class. So this is a dot plot from a very large class. And if I zoom into it, you can tell that this is a single peaked symmetric, almost symmetric distribution here. And the minimum is 2 and the maximum is only about 5.6, maybe 5.8. Whereas before, the minimum here was 2.8 and the maximum was 7.2. So definitely this is reduced the amount of variation that happened here if we use what's called a simple random sample. The definition of a simple random sample, which is the kind of thing we did here, is that every set of 5 words will have the same probability of being selected. Now that's doubly important for us because if we use a simple random sample, the results of a simple random sample are unbiased. So review again, every set of 5 words. It doesn't matter which 5 words you pick, maybe word 1, 2, 3, 4, and 5, that has the same probability of being selected as 187, 192, 256, 297, and 308. Every collection of 5 words has the same probability of being selected as a sample. So really important stuff here. Now, based on this dot plot, I feel really confident with what the mean should be. The mean should be somewhere right around that peak, and that looks just a little bit less than 3.6, but you know, for our sake, yeah, well, maybe 3.5. 3.5. And since this is single peaked and it has low variability, we feel really confident about what the average should be. Again, compare that to the distribution in number 3. And in number 3, a lot of variation, no single peak, much more difficult to tell what the average word is. And even if you were able to tell the average word length, I would imagine you would have less confidence in that average as opposed to the simple random sample. The simple random sample one just looks better, feels better, much easier to use. So how is the dot plot from number 4 different than the dot plot in number 3? We would probably say that the SRS dot plot, which is the one in number 4, has less variability and it has a lower mean than the convenience sample dot plot number 3. So based on what we see here, which one of these do we think is actually the mean word length? Well, the mean would be about 3.5 based on the SRS dot plot. Now let's go over to the sample here where I have all the words added together, and let's try to find the average. Since we have a computer, we can find this, the true average right over here. And I'm going to do a little bit of magic here. We're going to, in this cell, we're going to say equals the average, and then we're going to highlight this, what we want to average, and we want to average from word number 1 all the way to word number 297. So we'll take a little bit of scrolling, but you get to see me do it live. 297, almost there. There we go. And what was the actual average? 3.56. So the true average, our mu, equals 3.5. So 3.5 versus 3.56, we were actually much closer using the simple random sample than we were using our convenience sample. So there's another reason, actually it's the same reason. When something is unbiased, it means that what we're measuring is equal to what we think we're measuring. So we thought we were measuring the average word length in Crazy in Love, or our sample was meant to measure the average word length in Crazy in Love. And we actually did find the average. We said 3.5, and it was actually 3.56. So what we were measuring was the same of what we were supposed to be measuring. So number 7 here, it says that Beyonce wrote lyrics for all of Destiny's Child songs. The average word length for those songs is 3.64. Based on the samples, do we have good evidence that Beyonce did not write the lyrics for Crazy in Love? So we're not trying to say that she didn't write them. We're just trying to show, do we have evidence that she didn't write them? Or does the evidence point to she did not write Crazy in Love? And let's take a look at the numbers. 3.56 versus 3.64. If you normally write songs with an average length of 3.64, is it unlikely that you would have written a song with an average word length of 3.56? Probably not. Those two word averages are very close to each other. I think it's a difference of 0.08 letters. That's not strong evidence. 0.08 letters difference between the two averages is not very much. So there is not strong evidence to suggest that Beyonce didn't write Crazy in Love. The average word length of Crazy in Love is only 0.08 letters less than Beyonce's known average word length. So look at what that says and what it doesn't say. So Beyonce may or may not have written Crazy in Love, but the average word length doesn't suggest that she did not write it. So when we're talking about this, you're going to have to get used to a lot of double negative language. That's kind of an unavoidable thing here if we want to be exact about what we're saying. So apologies to the English teachers everywhere, but the double negatives here, they kind of make sense in this context. Let's see what we have for our Check Your Understanding. We're beginning a whole section here on sampling methods. And in order to do sampling methods, we have to talk about first what is a sample and what is a sample, or where do we use a sample. So the first thing we need to say is, what is the population? Population would be the entire group of individuals or subjects that we want information about. So in this case, we want to know information about the words in the song Crazy in Love. So our population was the words in Crazy in Love. The sample would be the subset of individuals from which we collect data. So the sample in this case would be that subset of 5 words from the population of 297 words that make up Crazy in Love. Now, important for us to also say is statistics makes decisions based on samples. Okay? If you can just measure the population average, then you don't need statistics at all. In other words, for Crazy in Love, we didn't need statistics. We could have just found the average, and we did just find the average of all 297 words. But, of course, we need to practice on something. So instead of, Beyonce's Crazy in Love lyrics, maybe we want to do, figure things out about, every individual who lives in California, or every voting individual in California. Now, for every voting or voter in California, it's probably super difficult, and I know it's super difficult, just to survey the entire population. Population here doesn't mean population of California, remember? Population means the number of, or all of the voters in California. Slight difference. So since we cannot survey the entire population, we have to just take a sample and try to figure things out based on that sample. So we've already met one of the bad sampling techniques highlighted here, and that's the convenience sample. And that's just sampling individuals or subjects that are easy to reach. The other one here that we'll talk about is the voluntary sample. And in a voluntary sample, the subjects choose to be in the sample. A lot of times they say that this is indicative of like a radio call-in show or maybe an internet survey. Okay, when people choose to be included in the sample, usually they do so because they have a strong opinion. So you are biasing the results in favor of the people who have a strong opinion. So the results from your survey are going to be different than what the actual results are for the entire population. We've got better sampling technique is a simple random sample. Now, in every simple random sample, every grouping of the population is equally likely to be chosen. So we took groupings of 5 or subsets of 5, sample size 5. So every sample set of 5 would have the same probability of being chosen as a sample. Now there are 3 steps that you need to do. The first one is to label. And you saw us do that when we had the words numbered from 1 to 297. Secondly, you want to randomize the entire population. Maybe you're just using the numbers as a proxy for the population, ID numbers as a proxy for the entire population. And then you select based on that randomized list. To keep things fair, usually we just say, if I want a sample of 50 individuals, I'll take everybody in my population, randomize their ID numbers, and select the first 50 in my list. So important for you is to realize that the simple random sample does not mean that every individual has the same probability of being chosen in the sample. Now, that is a true statement. Every individual does have the same probability of being chosen, but that's a little bit different. Actually, it's a lot bit different than saying that every set of, let's say, 5 has the same probability of being chosen. We'll get more into that, especially when we start talking about systematic random samples. Okay, here's our 3 steps to SRS again, and let's move to check your understanding. So we have this would be a voluntary response sample. Now, why is this method biased? Well, people who are passionate about the cell phone ban are the ones who are going to be more likely to respond to that survey. And because those people are more likely to respond, the results of this sample are not going to represent the population. They're going to over-represent those people who are passionate about the cell phone ban. So is 85% likely to be greater or less than the percentage of adults who believe cell phone use while driving should be banned? And probably that's going to be greater than the actual percentage. people who call in or who respond probably feel really strong about the cell phone use being cell phones being banned. So people with opposite opinions are likely to respond. As I'm doing this, sitting here in 2021, these results from a 2008 survey are pretty funny. Certainly at this point, most people are not banning cell phone uses. So here we go with number 2. To help eliminate bias, a reporter from Parade decides that she will go out and ask people in person if she thinks drivers should be banned from using cell phones. She lives close to a local high school, so she goes to the parking lot at 3 o'clock and asks the first 100 people that she sees. So this is a nice indicator here. Ask the first 100 people she's going to see. So what kind of sample is that? Well, that's a convenience sample. She made minimal effort to represent the entire population in this case. This is a bad sampling method, or a biased sampling method. So this sample is going to overrepresent the opinion of those who are going to be in the high school parking lot at 3 p.m. Not saying that their opinion is wrong, not saying their opinion is right. It's just that this reporter is going to base the entire state of California on one parking lot in a high school at 3 p.m. That seems a little bit suspect. Those opinions are going to be overrepresented, and they probably are different than the opinions of the entire state. So, how could Parade Magazine avoid the bias? So what Parade could do is use a simple random sample from the entire population. Now, it's important for you to know that a simple random sample of the entire population of the state or the country is a time-consuming process. It takes a while. It's also likely to be a very expensive process because you need to go everywhere in the population. So those results are going to have minimal bias, but they're definitely not the easiest one to do, which is why you won't hear people talk about them very much. So that does it here for section 4.1 on AP Stats. We're going to definitely do more with samples and learn different sampling techniques as we move on through this section. So we'll see you next time here on AP Stats.